So what if we wanted to know exactly how much heat is required to make these phase changes to happen? So let's figure out how much energy it would take to go from negative 30 degrees Celsius ice to 105 degrees Celsius vapor with a mass of 50 grams. In order to solve such problems, we need to identify the specific heats of the different states of water as indicated in the screen and the numbers of heat of fusion and vaporization we previously discussed. So the first step in solving this problem is we are going to calculate first the negative 30 degrees ice to 0 degrees ice using the specific heat formula. Heat energy is equals to mass times the specific heat capacity times the change in temperature. So let's multiply the given numbers. 50 times 2.05 times 30 is equals to 3075 joules. Step 2 is to calculate the heat of fusion. Heat energy is equals to mass times the heat of fusion. 50 grams will be multiplied to 334 joules per gram is equals to 16,700 joules. Step 3 is to compute the 0 degrees water to 100 degrees water. Solution, we're using the specific heat formula, which is the heat energy is equals to MCOT. So 50 times 4.184 times 100 is equals to 20,920 joules. Step 4 is to calculate the heat of vaporization. So this time we are going to use the formula of heat of vaporization, which is the heat energy is equals to mass times the heat of vaporization. So 50 grams will be multiplied to 2,257 joules per gram is equals to 112,850 joules. Step 5 is to compute 100 degrees Celsius vapor to 105 degrees Celsius vapor. So we're going to use again the formula of specific heat, which is heat energy is equals to MCOT. 50 times 1.89 times 5 as the difference of temperature from final to initial is equals to 472.5 joules.